Hi everyone, welcome to my channel. In the previous video, we have covered these topics like basic terminology related to probability. We have talked about random experiment in events. We have talked about sample space, which is the set of all possible events of any experiment. We have talked about exhaustive cases and favorable cases. Exhaustive cases means all possible cases. Favorable cases means the cases which are desirable for that event in that particular random experiment. We have also talked about equally likely events. If the outcome of the experiment are all having equal probabilities, we call them equally likely events. We have also talked about mutually exclusive or disjoint event. It is a really important concept, so I would suggest you to spend few minutes on the same if you have never done it before. So the events which cannot occur together are mutually exclusive event. And we have also discussed a classical definition of probability, which was given by this formula. We have written that probability of this event E or any event is number of favorable cases divided by number of exhaustive cases. So this was the classical definition. There are definitely a few more definitions of probability which are empirical definition and axiomatic definition of probability. And I will take you to those definitions later in this course because in many real life situations this classical definition of probability is not suitable definition. But we will talk about those things later. We have also discussed complementary event. Complementary event means non-happening of the event. So we have discussed that probability of complementary event is given by this formula. Now, in continuation to our discussion, what topic we would like to cover here is addition theorem of probability. So you might have heard about this addition rule, that sometimes we add probabilities like this to get our desired outcome. Sometimes we multiply. And I often get this question from the students that how to know when to add the probabilities and when to multiply the probabilities. So it's an interesting question and there is a trick. I would like to discuss that trick later after completing my two videos on addition rule and multiplication rule. So here in this particular presentation, we are talking about addition rule. And link of my previous video in which these basic terminologies and definitions is covered is given in the description box below. Before we discuss addition theorem of probability, let me just briefly revise you some concept of set theory. If you have done some math course and if you know set theory and Venn diagram, it's a plus point. Even if you have not done, don't worry about that. We are just considering it so that you have a better understanding of addition rule. So don't worry about the math. We are not doing any complicated mathematical thing. So set theory is basically, suppose you have a universal set U. So universal set means the universe which you are considering for your event. So suppose in this set you have these elements 1, 2, 3, all natural numbers or all integers, positive integers starting from 1 and ranging up to 10. So this is your universal set. And suppose you have two other sets. Suppose your set A is uh, the numbers which are starting from 1 up to suppose 6. So your numbers are 1, 2, 3, 4, 5 and 6. Those who are from mathematics can understand that we can also write it in terms of notation x, where x belongs to n is natural numbers, and x is less than equal to 6. There are multiple ways to write a set. Now B is another set. B is the set of even numbers which are greater than 4. So I can write 4, 6, 8, 10, greater than or equal to 4. So whatever way we can define different sets. So suppose I am talking about these two sets as of now. Now I just want to introduce two notations here. One is union of sets. We denote by this notation here. We call it union and this is the notation. And another is intersection. We will talk about intersection, this A intersection B as well. Now we call this union of sets. I'm not sure why I'm not able to write here, but it is union of set. Basically, this is a set which is union of these two sets. Union means this set will going to contain all the elements of set A and set B, all the elements. So we start with set A. So the elements are 1, 2, 3, 4, 5 and 6. Now we look at the set B. In set B we have these elements 4, 6 we have already written, so no need to repeat these elements. And then we have two more elements, so 8 and 10. If I club both the sets together and if I take all the elements which are there in these two sets, this becomes union of the set. So one thing to note that we don't repeat the element which are already there in the previous set. So this is union of the set. And similarly, we can define intersection of the sets. Intersection is, this is the notation. The notation is like just this intersection. So in intersection of sets, what we do is we take the elements which are common to these two sets. So we look at the elements carefully and we find out the elements which are there in both set A and set B. So this is set A and set B. We can see that 4 and 6 are the elements which are repeating. So these two elements, if we put together, it becomes intersection of these two sets. And just revising it, it's not required to understand addition union of probability, but it will add on if you go through these things. Now intersection of the sets A and B is these two elements. One more thing I would like to introduce here is we can count the number of elements in the set and we denote it by this notation. Number of elements in set A, NA, and we just write, we can understand here 6 elements, so 6. Similarly, if I count the number of elements in set B, we denote it by this notation N of B. It is here 4 because there are 4 elements. There is a name for this thing. We call it cardinality of the set. Similarly, we can count the number of elements in A union B. Here the number of elements are, we can see 1, 2, 3, 4, 5, 6, 7, 8. So 8 elements. And similarly, we can count number of elements in intersection. So here we have only 2 elements. So these were the concepts of set theory which I wanted to discuss with you. Those who understand the mathematical notation can write it formally like this. A union B is the set of all those elements X, where X belongs to A or X belongs to B. So whether the element is belonging to A or B, at least one of them, if the element is in at least one of the set, it is going to be the part of union set. And similarly, if we want to denote intersection mathematically, so this is the way we write X, where X belongs to A and X belongs to B. It should belong to both the sets to become a part of intersection. For two sets, union means either this or this, at least. So we have these words, or at least one of them kind of thing. Then we look for union. And if we have these words and, both, all, then we look at intersection. Now let's represent this thing visually with Venn diagram. It will become more clear. 1, 2, 3 up to 10. A was the set of these elements 1, 2, 3, 4 up to 6, 6 elements. B was the set of these elements 4, 6, 8 and 10. A union B was 1, 2, 3, 4, 5, 6, 8, 10. And intersection we were having 4 and 6. This was U, basically universal set. So I have written S, you can write U. U, generally we use this notation in set theory because it represents the universal set. But here in context of probability, we call sample space the complete set. So I have written as whatever you want to write. Now how we can represent it mathematically? Suppose in this rectangle, sorry for the poor drawing. This rectangle represent the universal set. So whatever you call it, S or U. Inside this we have two sets A and B, and A and B are definitely the subsets of this set. Subset means some of the elements are here, not all the elements. Now when we write A, we represent it with a circle. So suppose this is set A. A. In this set A, we have some elements. So the elements are 1, 2, 3, 4, 5, 6. We will fill these elements. And suppose we have this B set, which I will again represent with a circle. But we understand that these two elements are there common in these two circles. So we need to draw it so that some part is overlapping. So it is my set B. Now we can write the elements which are there in these sets. So my elements are 4 and 6 are common. So let me fill 4 and 6 here at the overlapping part. In B I have remaining these two elements 8 and 10. In A I have 1, 2, 3, 4 is here. So 5 and 6 is here. So order doesn't matter where I am writing, it doesn't matter. So basically this is my set A, this is my set B. And any other element which is not covered by these A and B, if we check here we have 7 also and 9 also which we have missed. So 7 and 9 somewhere in this universal set. Now this is the diagram where we have represented universal set and these two sets. This portion of the set which is overlapping or common to both the sets, we call this intersection. And we understand by definition, intersection of sets means the set of all those common elements which are there in both A and both B. And by definition, union is the set of all those elements which are there in either A or B. So if I want to represent union of the events here graphically, can you take a pause and think what would be the area which would be covered by union of the set? Union of the set is this area of set A plus this area of set B, including this intersection part because it is also there in the union. You can see in the union we have these elements 1, 2, 3, 4, 5, 6, 8, 10. So all these elements should be there in the union set. So the area which I have shaded with the blue color is A union B. So by this Venn diagram, we can infer many things that if we want to count the number of element in A union B, which we can count here directly as well in the simple example. But if for a complicated problem, we want to get the number of elements in the union B, we can use this Venn diagram and come up with the conclusion that this is exactly equal to number of elements in set A plus number of elements in set B minus number of elements, let me write here, number of elements in A intersection B. Number of elements in set A. So I have added this quantity plus number of elements in set B. So I have added these two. But when we added these two, this portion which is common to both the sets is counted twice. So what I need to do is I need to subtract these elements once. And we can cross check here. We understand that number of elements in set A is 1, 2, 3, 4, 5, 6. 6. Number of elements in set B is 1, 2, 3, 4, 4. And we have counted these two elements twice. So let me subtract. So it is going to be 8. And we have seen here that we have 8 elements in this thing. So here we got a wonderful rule. Number of elements in set A union B. And we can use this to get our addition rule of probability. Can you count how many elements are there in your universal set? It is 10. And by definition of probability, we understand that probability of any event is equal to favorable cases divided by exhaustive cases. So if I am looking for probability of event A, it is the number of elements in set A divided by number of elements in sample space. So it is 6 by 10. Similarly, we can say that probability of event B is 4 by 10. Similarly, we can say that probability of A intersection B is equal to 2 by 10 and probability of this is union, it is 8 by 10. So if we divide this rule by ns, what we get here is addition rule of. probability. We get this thing, probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Just what we have done is we have divided all the quantities by ns, which is number of elements in the sample space. And by now you must understand that number of elements in the sample space are exhaustive cases. So we got this rule. So this rule is known as addition rule of probability. Till now we were just deriving addition rule, but we will look at the some of the problems there. It will be more clear to you that how to apply addition rule and what are the situation where it is suggested to apply addition rule of probability. Formally, this is the addition theorem of probability, that for two events A and B, probability of happening at least one of them is, we denote it by PA union B, and this is PA plus PB minus PA intersection B. So we have just derived this equation, and we have also discussed that when we see these words at least, we see these words either this or this kind of words, then we need to apply this thing, because union itself represent at least one of the events happening. So this is how we know that we can use addition rule only when we are interested in probability of at least one of them happening or either of them happening. So then addition rule is applicable. So I hope you are getting the trick here. We will discuss about it later on again. Now, one more special case you can refer is when the events A and B are mutually exclusive. We have discussed mutually exclusive events in our previous video. So when the events are mutually exclusive, we understand that event A and B cannot happen together. It's not possible to get these two events happening together. So in that case, probability that these two events will happen together is going to be 0. So it means probability of A intersection B is 0. I hope you understand that A intersection B represent that these two events will happen together. Both A and B will happen. So if we put this quantity 0 in the previous equation here, this becomes 0 and we get the rule PA union B is equal to PA plus PB. And we can again see it with the Venn diagram as we have done earlier. So this is my sample space and these are events A and B. And because nothing is common, the events are disjoint, then the sets are not overlapping. And we are interested in finding out this set A union B. This is the sum of this set plus this set. There is nothing in common, so nothing to subtract here. And this is the mathematical way of writing that the set A intersection B is an empty set. Those who understand set theory notation. Let's take some of the example to make it more clear. Here is one of the very simple problem. The probability that a student passes a physics test is this. I would suggest you, when you are reading the problem for the first time, read it slowly and try to find out what are the events they have defined. With this line, I am able to understand that the event is student passes a physics test, and we know the probability of this event. So we need to define the events first of all, and we need to write whatever information is given to us. So first event is passes physics test, and this is given to us that P of A is 0.65. 65% chances are there that a student will pass a physics test. Now next part of the question says and a maths test is 0.55. So we see there is another event B that the student passes maths test and probability for which is 0.55. These two things are given to us. One more information is given to us. The probability that student passes both tests is this. So by now you must be having an idea. Both means A intersection B. Both of the events happening. And probability of this thing is given to us 0.25. Now these three things are given to us. And they have asked us to find out the probability that he will pass at least one of the tests. These are the keywords to solve any problem, both here and at least here. At least means we are interested in finding out the probability of union of the events. So this is the question, and I hope it's very clear that we need to add these probabilities, and because the probabilities are not for disjoint events, we need to subtract this thing, A intersection B. So here is the solution we have done, and this is 0.95. This was one simple example. Let's look at one more example to make it little more clear. Suppose we throw a die. What is the probability to get an even number or a 3? This is the keyword or. When we see these kind of words, we understand that we need to apply addition rule. So we need to find out union of the event. This thing. What are the two events for which we are interested in looking at the union? First event is this even number, second event is this 3. So in case of a die rolling example, we understand the sample space is this 1, 2, 3 up to 6, and first event is getting an even number. So these are the favorable cases for this event, and similarly second event is getting a number 3. So this is just one favorable case here. So we can first compute the probabilities of these events. Probability of A is 3 favorable cases and 6 exhaustive cases. So this is 3 by 6. Probability of event B is 1 favorable case divided by these 6 exhaustive cases. So it is 1 by 6. And now we can compute the probability of A union B. But we need to think before computing this that whether the events are disjoint or not. So look at these sets here. This is 2, 4 and 6. This is 3. There is nothing in common. So if we look at the Venn diagram, we understand that A intersection B is an empty set. There is no element in A intersection B because there is no common element in these elements. Otherwise also, if we look at the concept, getting an even number and getting a 3, this cannot happen together. If the number is an even number, it cannot be 3 because 3 is not an even number. So we understand that these events are mutually exclusive events. So we will use this formula. Here in this case, we just need to sum up the probabilities 3 by 6 and 4 by 6 to get our desired. Now we have discussed just addition theorem. In the next video, we will be talking about multiplication theorem. And you can read some of my interesting answers. I write a lot of answers on Quora, Stack Exchange, ResearchGate, and so on. Quora is the platform where you can read my answers, which are detailed and maybe layman's terms description of your problems. So if you find those answers interesting, you can always refer. And if you want to contact me or reach out to me for your problems, you can reach out to me here. Thank you so much.